Yes. So, a very good morning to one and all present here. I am Yanda Carvalho, and I feel privileged to welcome you all in Multicon 2022 on behalf of AAC TCET. The main goal of AAC Student Chapter is to encourage its members to study civil engineering and advance the profession of civil engineering. So our workshop focuses on the software MATLAB, and yesterday Sir had showed his insight and he has shared all the shortcuts which can be used in MATLAB software. He also displayed how we can obtain information about different parameters of for different math function in the software. So participants, if you have any doubt regarding any part in the session, you can just unmute yourselves or you can just drop a message in the chat box. So without further ado, I'd like to turn over the session to Rafiq sir.
Okay. Thank you, Leander. Hello and good morning, everyone. This is the second session for the workshop. It is scheduled for the 2 days, 25th to 26th February. And today we are going to have a second session. Let's start without any further delay. Yesterday, we took over session 1 and we talked about how to use MATLAB, install MATLAB, and the trial version, how to access the MATLAB, what is the user interface of the MATLAB, what does all the command window editor, workspace, and all that mean. Just give me a second. Let me turn on my video so that sometimes I show up. Okay. So we tried some basic examples in the MATLAB. We used MATLAB as a calculator where we tried out different assigning different variables, how to override the variables, how to deal with the error message, how to control the hierarchical function, how to get help from the MATLAB, and this was the main focus. And some more tips about the mathematical, elementary, as well as specialized functions, how to control the appearance in the command window. So all these we have done yesterday. So today we are going to deal with the session 2. I hope that everyone is ready to start. So I am splitting my screen into two so that yes, uh, so that I can simultaneously show you the presentation as well as the MATLAB working space. So I will continue to use MATLAB online version. I hope that all of you log into your MATLAB accounts and you know how to log in. So there is some account which already logged in. I will continue with that, whether that is my IITB official account or whether that's my personal trial version, which I have created yesterday for your demonstration. Yesterday we looked at we try to start with the installation and assessing MATLAB. Like from the objectives of this MATLAB workshop, we have covered these three yesterday, and now all these will be the focus for today. So we have seen how do we use MATLAB as a calculator. Now we will go to matrices, and we have yesterday tried to enter some matrices and vectors. I will restart from that. Let's suppose that I have to create a matrix A and which has the 3 rows and 3 columns. I will input the first row, 1 space 2 space 3. Then I will move to second row by typing semicolon 4, 5, 6. Similarly, I will move to next row. For the demonstration purpose, I don't put semicolon at the end so that all of this prints to my command window. But again, I will format compact to save my space. Okay. Now I have created a matrix A, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. Now I will play with this matrix to let you know how to do the things. Yesterday we have seen that how to call any element at any row, at any column. For example, I want to call the element at the second row, comma third column. And I will write A of 2, comma 3. It means just tell me the element which is at the row 2 and corresponds to the column 3. Row 2, column 3 means 6. So it's showing up 6. Similarly, yesterday I have seen that I have demonstrated how to create a vector without inputting all its values. Let us suppose that I want my vector from 1 to 10 with difference of 0.25. Okay, let us suppose 1 to 5. Then what I will do, because I have yesterday demonstrated the use of colon operator, which shows that let us suppose I want to get a vector x, which equals, first of all, I need three inputs. One is the first value and the last. First value is my 1. Then what I need is use of colon operator. Then input my increment. I want to increase the value by 0.25. Then my last point. Let us suppose last point is 5. So whole of my vector is created, which contains the values 1, 1.25, 1.5, 1.75 up to 5, as I asked my MATLAB to do for me. Now, sometimes I don't know what is the length of this vector. Length of vector means what are the number of elements contained in the vector. What I have a function for that, which we call as, for example, length is length of x. X is any vector, like this is any vector, whatever you have assigned your variable. Because as of now, I have assigned x to my vector, so I will input here x, length of x. If I can either just enter so that it will be assigned to the variable answer. It means that there are 17 elements. Or else what I could have done is I could have written I would have assigned this number of elements to some other variable, like n is equal to length of x. What it does is it creates a variable n with the value how number of elements in the vector. Okay, someone wants to say something? Or it is accidentally. Okay, let's assume that someone has accidentally turned his or her mic on. Now, there's a concept, what we call as linear spacing and log spacing. Let me clear my command window. Linear spacing means I want my number of points, like I have created a vector. I want a number of points or we can say number of points in an array, but those have a similar difference between. But I don't know what should be the difference. Earlier, I was knowing what should be the difference. Like I have created here x from 0 to 1, 0.1 to 5. Like I have created x from 0 to 1 to 0 to 1, 0 to 1 to 0.25 to 5. Because at that time, I was knowing what is the difference between my consecutive points. In some cases, let us suppose that I want to do the reverse things. Like I know I want my pointers to be from A to B, but I don't know the difference between the points I want to have. I know the number of points I should have. So for that, I use the linear space command. Let us suppose that x equals, let's see, y equals, I will write the same thing. Y equals linear space of 0, 5, comma, I want the number of points as 17, let us suppose. And I will click enter. What it shows is, okay, let me change it from 1 to 5. Okay. So what it did is it created this is also right, because this is just depends on what is my intention? Whether I want to create, this is the first element, my last element, and this is the total number of elements. It will divide it, all the number of elements in a with same consecutive difference, just like an arithmetic progression. So you see the difference between x and y. X and y is same. So what is the difference? When I declared the x as an array, I knew my what's the difference. So I didn't care about how many number of elements go into x. But sometimes my problem is like that. I know the number of elements in x, and I don't know what could be the difference, and I will not calculate it. So I will ask with MATLAB to create a linear space for me, and so that mm, number of elements are fixed, and it will automatically determine the difference. And similarly, for example, I want to create a series of theta, series of angles, which I will assign to a theta. So I want to calculate theta equals linspace of, it means that I want my number of points from 0 to, let us say, 2 pi, 2 into pi. 2 pi means 2 into pi, comma, how many number of points I want? Let us say I want 101 points. Okay, or 100 points. It depends on the problem I am solving. So what will it do? It will create a vector and store it into a variable theta. The vector will have elements 101. The first element will be 0. The last element will be 2 pi. And rest of the elements will be in the linearly between 0 and 2 pi. If I click enter, you can see the number of from 0 to 2 pi is actually means 2 into 3.1416, which is 6.2832. And these are the points which have the consecutive same difference, or what we call as AP. Similarly, there's a concept of what we call as log space. It is just similar to log space is just similar to linear space. What it only does is when we go to the log scale, because sometimes we want our values to be in the log scale. So if you want to create the points which are equidistant from one another, or which have the equal distance between the two consecutive points, but in the log scale. Earlier we used the linear scale. In that case, we can use like log space of, I want my points to be from 0.1 to let us suppose 100. I want my points to be distributed from 0.1. First point will be 0.1 and another will be 100. But with the number of points, let us say 11. What will it do? So it creates the points, but let me start actually 0. Format long. Format long. I have inputted the wrong spelling. So I will see what is contained in my. Okay, actually it will be 10 to the power. This is 100. This will be 0.1 and others will be, yeah, actually it has multiplied with the 10 to the power 100. Like all these columns are multiplied with 10 to the power 100. So I will take some different examples for the demonstration. Logs z equals log space of, I want my points from, I want to create the 3 points from 10 to 1000. What it will do? So it creates my points. 1 into 10 raised power 10 is 10, and others go to infinity. And this is actually a raised power 1000, which here goes out beyond the MATLAB capacity. Similarly, we have seen that colon operator, what it does in the arrays. Now let us try to use the colon operator in matrices. I already have a matrix A stored in a workspace. A has 1, 2, 3, 4, 5, 6, and 4, 8, 9. because earlier I have changed this value. Now what I will do is I will just change the value of this element. What is the index of this element? Index of this element will be, it is contained in the third row and the first column. I will change it to 7. So my matrix now A becomes 1, 2, 3, 4, 5, 6, 7, 8 now as I desire. Sometimes, like when I am doing calculations, what I need is I need some particular element of like a particular row or particular column. At that time, I use the colon operator. Let us suppose that I need to calculate the third row with all the columns. Because earlier, what I was doing, when I was doing 3, like if I shade 3 comma 1, then it will give me the this value. If I tell it to, if I write A of 3 comma 2, it will give me 8. Similarly, if I write A of 3 comma 3, it will give me 9. Sometimes what I will want is I will want all the 3, but I will try to, I will write only a single command for this. So what I will do is A of what is the row which you want to print or which you want to be in some variable. So my row is 3. What is the column? We use it here: first column, second column, third column. I will tell it that I need all the columns. So I will write column. So in the matrix indexing, column means all the columns or all the rows. If I write, so it will store 7, 8, 9. I can assign it to the variable as usual. Like I will write a row 3 equals A of 3 this. So there's a variable row 3 which has been created and it contains 7, 8, 9. Similarly, I can do the reverse. If I want all, if I want a particular column and all the rows, let us suppose I want 2, 5, 8. What I will write? Here, my rows will be all the rows. First, I have to write rows. Rows means all. For all, I will write column. Then I need the second column. So what will it print? 2, 5, 8. I can assign the variable whichever I want. And also, what sometimes I may not want all the columns or all the rows particular. What I may want is just the all the rows, like the third row. Let's suppose the third row, and only the column number 2 and the column number 3. From column number, sorry, from column number 1 to column number 2. But elements of row 3. So I will write A of elements of row 3 column. I will not write here this. I can write 3 comma 1, then I will write separately 3 comma 2, but I will not do that. 2. Here column means when I will write simple column, it means all. If I write the two numbers in between them, it means my column runs from 1 to 2 and the row corresponds to row 3. So this is the values which are stored in this. Okay. Similarly, I can change. For example, I want to change these two values. What should I write? Let us suppose I want to change these two values to 0. What should I write? Can someone tell me? Okay, I want to change the values of this 5 comma 6 to 0. So my row corresponds to 2. So I will write a 2 comma. Columns correspond to second column and third column. So 2 to third. Okay. Second row and the columns correspond to second, third. I will write it equal to 0. Just see what will happen. So my matrix gets changed. A 1, 2, 3, 4, 5, 6 has now got changed to 0, 0, and now it is 7, 8, 9. Okay. So I will again rewrite the matrix with the earlier matrix. So we have A stored as 1, 2, 3, 4, 5, 6, 7, 8, 9. No. A of 3, comma 1 needs to be stored as 7. Then only. Okay. Now we have matrix A. Like for simplicity, we're writing it 1, 2, 3, 4, 5, 6, 7, 8, 9. You can take any matrix. Okay. Sometimes we want to create the matrix, submatrix. Submatrix is like any column. If I take any column, any row, which is of this size lower than the A, and all are contained in this, that's what we call a submatrix. Okay. You all know that. Now, I want to create a submatrix from the A. I can simply do that. For example, I will write B equals, okay, A of 2 comma 3, A of comma 1 comma 2. I already told you what will this do. First one is row. I am defining the row numbers. Second one, I am defining the column numbers. It means that I am asking my MATLAB, let me put 1 comma 2. So I am asking my MATLAB to store the values from the matrix A to the matrix B, but the values should be from column number 2. Column number 2 is this one, 258. Similarly, sorry, row number 2, 456. Similarly, row number 3, but they correspond to columns 1 and 2. Let me check what will be the value. Okay, so corresponding to column number 2, row number 2, this is 4, 5, 6, 7, 8, 9. But I only want column 1 and 2. So 4, 5, 6, 4, 5, 7, 8 would be the matrix stored in B. Similarly, I will write C. I will store C in the matrix as a matrix A, like submatrix of A. But what I want is, I want to interchange the values, or I want to interchange the number of like rows, columns. Like, I'll show you. First of all, I will ask my MATLAB to write for me. First of all, write second row, then call the first row, then call the third row. So I change the order and write all my columns. So what I am expecting is this command will write a matrix A to the matrix C with the columns as first column as first row as second row, and the uh, second row of the matrix C would be what is the first row of the matrix A. Similarly, third will be the same. So using this command, I am expecting that my C matrix will be similar to the matrix A. Only difference will be row 1 and 2 will be interchanged. Let's try it out. Oh, you can see now my matrix C is 1, 2, 3 is here and 4, 5, 6 is here. Earlier it was like this. So I hope you get it. And now I want you to guess the result of this. I will write A, like I will store in a matrix G the A of n to -1 to 1, comma E and D. Okay. I want you to guess the result. If I put the enter, what will be the result in the matrix B? Someone who can tell me what will be the results for this?
No idea, sir.
Just try that. What will you do? Just first of all, try to understand. This will be my these will be my row numbers, which will be stored in a matrix G, and these will be my column numbers. And I have yesterday told that, and it takes the last value. So what I am doing, let me make you understand that what will be the rows and what will be the columns. And mean is the last. I am expecting that in the matrix D, the column will be the last column, 6, 3, and 9. Okay, like last column is this one. But what will be the values? It shows me that and for row, my end row is third. So it will do is 3 up to, and then it will decrease the value with -1. It will increase the value with -1. And then at last it will go to 1. Because let's see. I don't want to show you it right now. My end is 3. If I write, it is actually equal to this 3 minus 1 up to 1. So what gets stored? 3, 2, 1. Then I am writing D equals A of and up to -1 to 1, comma, and. You know that and means here the last row, here means the last column. So it will be 3 to -1 to 1. When I write 3 to -1 to 1, it will automatically here as if I am writing 3 to 1. It means my rows will be 3, 2, and 1, and column will be the last column. So what I will expect in the D is, first of all, I should have 9, then 3, then 6. Let me try it out if I am right. It is 9, then it is 6, then it's 3. No, sorry, it should be like this because I'm calling the matrix A. It should be first of all 9, then 6, then 3. Okay, I am dealing with matrix A. Similarly, if we try to delete the row, just give me a 1 second. Okay, I have a matrix A in which I have a matrix A in which I have stored 1, 2, 3, 4, 5, 6, 7, 8, 9. Just some issue with the internet, something. Why does it not take the values? Let me relog in. Okay. So I want to delete some row or column. What I will do is, let us suppose that I want to delete the third row. Just similar. What the third row? What will be the indexing? My third row and columns will be all the columns. Okay. I will write it equal to nothing. Null matrix. This means null matrix. Got it? Like I write the square brackets without any element inside it, it means null matrix. Oh, my A has changed and its size is also changed. Now it is 1, 2, 3, 4, 5, 6. Similarly, I want to, sometimes I have a matrix, I don't know. As of now, I have a matrix. Yeah. 7, 8, 9. So I have a matrix which is stored as 1, 2, 3, 4, 5, 6, 7, 8, 9, just for the demonstration purpose. So I may not know the size of matrix. Size means what are the dimensions of the matrix. What I will do is, if I just simply click size of any matrix and I write the matrix, my matrix is A. It will give me 3 cross 3. First one will be the number of rows. Second one will be number of columns. For example, I want to calculate because this is my x is my row vector. Okay, I want to calculate the size of row vector. What should be the size of the row vector? It means there will be multiple columns and a single row. Let's try this out. Size of x. Size of x. This is the single row and the 17 columns are there. And now if I want to assign these size to some variables, what I can do is I can write like this: m comma n. It means that just store, let me write this, just store the number of rows of a in the variable m and store the number of columns of a in the store n. So m comma n is equal size of a. Earlier it was just assigning it to the matrix a. It means now two variables have been created here in the workspace. M equals 3, N equals 3. If I have the different matrices, I can definitely try these out and it will automatically tell me what is the. And I have yesterday told you what is the use of the continuation. 3 lines. If I want to write a big matrix and I do not, like, if I click the enter, it will take me to the second row, and I do not want that. I want to write in a single line. So this has already been demonstrated yesterday. And sometimes I may want to take the transpose. I want to write a matrix B, which is the transpose of A. What I can do is I can simply write transpose of A. You can see B is the transpose of A. Just 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Or else what I could have done is B is equal. There's a simple shortcut that A is bar. This is the simple shortcut for to calculate the transpose. You can either write transpose of A or write A bar. So, do you know what we call it? What do we mean by concatenating? Concatenation. There's something we call as concatenation. Concatenation means just to join the two. Okay. Sometimes I want to join the two matrices. I can do that, or 2, 3, or as many matrices I want to join. So I can do that. And this concatenation will be very much helpful in the when you try to do the actual problems. Okay, because uh, you will have to collect all these commands, simple commands, and that will really make you a very useful code which you can use in your actual projects. Okay, let us take a view on some concatenation. So I have a matrix A, which is already stored as 1, 2, 3, 4, 5, 6, and 7, 8, 9. What does it mean? What does it mean me to double? 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, I want to write a matrix B as this. Let me just copy it from here so that because I'm a bit lazy to type. Okay. Can someone tell me what could it be doing? You see, just look what I asking my MATLAB to do. I am asking my MATLAB to store a matrix B, and because this tells me this is a matrix. I am defining a matrix. So care brackets tell me I am defining a matrix. Okay. First, to store a matrix A in the matrix B, it means that I will have a matrix. Somehow. So what I am doing, I am asking my MATLAB to store the matrix A, and then on the side towards the right, like in the other rows, okay, store my matrix 10 times A. I am multiplying the matrix with 10, just the scalar multiplication. Okay, then I am telling it to store the matrix minus A, which will be equal to minus 1 into A, and then write this matrix, because this is my identity matrix. You might be remembering, because if I write this matrix somewhere, what will it do? Like in the first row, 1 0 0, then 0 1 0, then 0 0 1. Just see, if I click the enter, what will happen? First of all, my matrix A has been written here: 1 2 3 4 5 6 7 8 9. Okay, then 10 times matrix has been written: 10 20 30 40 50 60 70 80 90. Then it has hit the enter, and it has come to the next row. Next row, You might be getting, because this means I change to the next line, to the next row in the matrix. This is minus a. Here, this is minus a. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9. Then I ask it to write identity matrix for me. I could have asked it to write some different matrix, and it does that for me. 1 0 0 1 0 1 0 0 0 1. This is what we call as concatenation of matrix. And you will have to use this concatenation more often during your during scripting, which we will be dealing later on. Now, you might be knowing that we have a different special type of matrices. We will try out some. Even like sometimes we want to generate a matrix because, for example, I have to write this 1 0 0 0 1 0 0 0 1. I don't like. So, what I have earlier, yeah, how I earlier wrote is like a 10 into a minus a, and then I wrote identity matrix. Sometimes if I have to write an identity matrix, which is of the order 10 cross 10, which is of the order 100 cross 100, of the order thousands cross thousands, what I will do is I will not write that matrix manually. Instead, I will just ask it to write a matrix, identity matrix EYE of 3. If I write EYE of 3, what it does is it will create an identity. EYE is the function for my identity matrix, and 3 is the what should be the size of matrix, because you know identity matrix is always square matrix. It cannot be rectangular. So if I am defining the square matrix, I only need to one input. Okay, because the number of rows are equal to number of columns. So, okay. I just need to some readjustment in my. Is my signal still visible? I just wanted to confirm. There has been some. I have made some things.
Yes, sir. Screen is visible.
Like what exactly is visible on the screen? Like, do you see
Your
I'm using a
MATLAB.
MATLAB?
Yes, sir.
Okay, thank you. Thank you. So, what I wanted to show you is that, like, there's a function in the MATLAB, what we call as the identity matrix. For the identity matrix, we have a function EYE. It will create an identity matrix of the order 3 cross 3. If I only input the 3, it will create me 3, 3 cross 3. Just look. What it does, it created the same matrix that was done earlier. 1, 2, 3, 4, 5, 7, 8, 9. This is 10 times a, this is minus a, then this identity matrix. So to save my time, to save my efforts, to save my energy, because I have a lot of options available in MATLAB. Similarly, I have other options available in MATLAB. For example, I want to create a matrix of some order. Let's suppose 5 cross 10. So I want to create a matrix F of the order 5 cross 10, and it all contains zeros. All the values contain zeros. So these are the special matrices. So what I will do is zeros of like 5 cross with the 5 rows, 10 columns. Here is your matrices. 1, 2, 3, 4, and 5 rows, and these will be number of columns. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Similarly, if I tell it only zeros of 4, what MATLAB will understand that? Okay, you want me to create a matrix of the order 4 or of the size 4. If I am not inputting the two variables, it means that I am asking you to create a square matrix. Okay, even I can write 4 comma 4. It will, or I can write zeros of 4 simply. It will automatically understand that you want to create me a matrix of the order 4 cross 4, and I am only inputting one variable. It means that I am asking MATLAB to create square matrix. And if I want to create an array of zeros, let us suppose a column of zeros, then I definitely need to. I cannot. If I write zeros of 4, it will create me a matrix zeros of 4. In that case, I will have to also get to create 4 rows for me, comma, and only one column for me. Then it will create a column vector for me. Here you can't directly write zeros of 4. Similarly, if you want to create a matrix of which contains all the elements as 1, then you can calculate G is equal to ones of, let us suppose 5. It will calculate 1 1 1 1 5 cross 5 matrix. Similarly, if you want the rectangular matrix, you can just change here 5 comma 3 or whatever you want. Like I have here is m comma n. Okay. There is something we call as random matrices, because sometimes we may need to create a random number. Okay. So there's an option in the MATLAB. What we do is, for example, I want to write a matrix of C as a 4 cross 4, 4 cross 4, or I could have written 4. Then I enter. What it does, it creates format short for so that it is easily visible. Okay, C is random 4 cross 4. Rand means random. So what it does is it creates a random number between, at each element it creates a random number between 0 and 1, between 0 and 1, between 0 and 1, between 0 and 1. And similarly, we have other special matrices like magic matrix, Hilbert matrix, inverse Hilbert matrix, Wilkinson matrix. You will all look into this. Like I wanted to ask you if someone knows what is the magic matrix. Does someone know what is the magic matrix?
No, sir.
Okay, can someone, like, I will ask my MATLAB to cross a 3 cross 3 magic matrix. Can someone get it from here? What exactly is the magic? What is the logic behind the magic matrix? Here is the magic matrix of 3 cross 3, or B is the magic matrix of 2 cross 2. Can you look at the pattern and okay, yeah, this is only the square matrix and it only accepts 1. Okay. Okay. So I am dealing with magic matrix. So my magic of 2, magic of 3. Can you look at this and see there is some pattern? I just give you 2 minutes to look at this and tell me there is some pattern. It is applicable only for the order 2 to 3.
Sir, all the numbers are 1 to 9.
It is only applicable to the order greater or equal to 3. Just look at this. Okay, let me take you through this. Do you see there is some pattern? Like all the numbers are between 1 to 9? this you have seen in Magic 3, but in Magic 4 it does not follow that way. Just can you see what is the sum of this 8, 1, and 6? 8 plus 1 plus 6 is 15. Okay. 3 plus 5 plus 7 is 15. 4 plus 9 plus 2 is 15. Similarly, if you see any column, 8 plus 3 plus 4 is 8 and
Sir, but all the number is
11.
used once.
Yeah, all the numbers are used once, and the sum of each column will be equal to sum of each row. 1 plus 5 plus 9 is 15. 6 plus 7 plus 2 is 15. If you even take the diagonals, let's suppose 8 plus 5 plus 2. 8 plus 5, 13 plus 2 is 15. Similarly, 4, 5, and 6. This is 15. Similarly, will be the case with the Magic 4. 16 plus 2 is 18. 18 plus 3 is 21. 21 plus 13 will be 34. Similarly, if you take any column, let's suppose 10 plus 3 is 13. 13 plus 6 is 19. 19 plus 15 is 34. If you take even diagonal values, so these you can just check in the MATLAB what are the special matrices available and how you can generate them. Because you might need it. You might need it at this is not just this is a magic matrix, because we usually need it when we solve the problems, different problems. Now let us come to the arithmetic operation. This is we have seen how to create the matrix, how to create the submatrices, how to deal with how to change the values of a matrix and all that. Now we will come to the actual part, what is called as arithmetic operation. Because now you have entered a matrix. Okay, now I will clear all my workspace, including my command window. Okay, I will write a matrix as A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, someone tell me the matrix of 3 cross 3. Or I will write matrix as this 2, 2, 4, 5. Okay, then I will try to add this too simple. It is simple if I add the two matrices. Okay, just as if I am adding the two numbers. So I will write a C as A plus B. What will be my answer? Can someone tell me? What is the answer which I should expect in the C? Because matrix addition is so simple, right?
It will add in first 2 rows and 2 columns of A, then other 3 will remain same.
Okay, you mean to see that C will contain the first element as 1 plus 2 is 3, and the second element as 2 plus 2 is 4,
Yes,
and only the 4 elements will be changed in the A, rest will be same, right?
Yes, sir.
But you forgot the point that there is a rule.
Yes, sir.
Until and unless you don't have the matrices of the same order, you can't add them. So I tried it. Let me try. I will put the enter.
Yes, sir. It will
shows
say error.
It shows error, and it shows what is the issue. It tells me that actually arrays have incompatible sizes for this operation. Okay, and because I already know addition or subtraction for the two matrices is only possible if they have the same size. What I do need to do that now. Even if you do it. Now I will create a different matrix. This is not an issue. Now I have a matrix now B and A. A is my 1, 2, 3, 4, 5, 6, 7, 8, 9, and B is some different matrix. I want to add them. What I will do is I will write matrix C as simply C equals A plus B, and that. What will it do? What it does is it adds the element 1 to the element 1 as what is the usual operation in the matrix arithmetics. Similarly, if I want to calculate the matrix C as the A minus B, I can do it. It will do that for me. Now, if I want to calculate the matrix A and B and then store it as A cross B, I can write it as B equals A cross A into B. Simple multiplication. It will multiply it. Okay, because you know the matrix rule. How do we multiply? How much time it takes when we try to multiply? Okay, or else we could have write D1, some other variable, into B cross A. Do you know that A and B, A cross B, and or A into B and B into A in the matrix are different? Here you can see this is not same. Here 25, here 17, here 39, here 22. It means that AB and BA are not same. So sometimes I want to secure the matrices. It is just as simple as I have told you yesterday. I use for exponent, I use this sign. Exponent, this is what we call as exponential sign, and then 2. It will, what will it do is it will calculate me A square. A square means A cross A. Or I could have written A into A. But if I have to write A into A multiple times, then at that time I will prefer to write, you can see this A into A is A square and the values are same. Okay, sometimes I have to write A into A up to 5 times. I will not do that. I will just simply do A raised power 5. It will do A cross A into A into A into A. And it will calculate you. Okay, you can just store it in some variable. Sometimes you know that when we multiply a scalar to the variable, okay, I have a matrix A which contains 1, 2, 3, 4, 5, 6, 7, 8, 9, and I want to multiply a scalar. Scalar means some number. Okay. When I calculate some number, okay, for example, I want to multiply the matrix by 2. What I will do is I will just write 2 into A. So whenever we write the 2 outside the matrix during our normal, whenever we solve the matrices, what we mean is we want to multiply this 2 to the every element. Let us see if it does the same. Yeah, if it does the same. 1 and 2 is 2. Similarly, 4, 6, 8, 10, 12. This is exactly 2 times what was my matrix A. Now let us come to what we call as element-wise operation. Sometimes you will have a matrix, like I have a matrix A, I have a matrix B. If I write that simply A cross B, what will happen? It will just multiply. It will just multiply A into B. But what I actually want is I want to multiply this element to this element and this element to this element. Like I want to multiply the corresponding element of one or a particular element of A to the corresponding element of B. That is what I call as element-wise operation, not the matrix operation. A into B is a multiplication of matrices. But I want my values to be multiplied with their corresponding values. Let us say that I want this to be multiplied with this and this to be multiplied with this. At that time, I will write, for example, E is a matrix which will contain A into B. Is that right? Will it do the same which I intend to do? The answer is no, because it will just take it as a multiplication of 2 matrices. If I insert the point in between, okay, this point signifies, tells the MATLAB that you are supposed to do the element-wise operation. What you have to do is corresponding elements of A have to be multiplied with the corresponding elements of B, not the matrix multiplication. Let's try it out. Okay, 1 into 2 is 2, any element. 8 into 9 is 72. Similarly, 6 into 2 is 12. Sometimes you may want matrix multiplication, then you don't have to insert dot. If you want element-wise operation, then you have to insert dot. Earlier, I calculated A square. Okay, this was A into A. Now I will calculate it A square, but I will insert dot in between. What will it do? It will calculate me this is my A. It will calculate the square of every element inside it. This is what we call as element-wise operation. 1, 2 raised power 2, 3 raised power 2, 4 raised power 2, 5 raised power 2, similarly like that. Okay, sometimes like let me show you. I have a matrix A and then I have a matrix B, and I want to raise power each element of this B to this. Like I want to calculate 1 raised power 2, 2 raised power 2, 3 raised power 1. So every element of A, I want to raise, like calculate it raised to the power of element of B. So what I will do is A raised power B. Can I do that? No, it will not. It will not calculate. Let's try. It will show me that this is an error. These are incorrect dimensions. You can't do this. Okay. So instead, even though the MATLAB is so small that it tells me if I sometimes forget to dot, it even tells me from there. If you want to calculate the element of matrix powers, use dot then exponent. Okay. This is what I wanted to show you here. If I write a dot exponent b, this is what will happen. Okay. Like 8 raised to power 9 will be this. 4 raised to power 4 will be 256. Similarly, like there are two, we want to calculate the inverse of any matrix. Okay. For example, I know that I have matrix B. I want to calculate the inverse of this. I know that if I want to calculate it on the page, on the paper, normal pen and paper, it will take me a lot of time. So we have a function in the MATLAB what I call as INV. It means inverse. Inverse of, I will write inverse of B, simple. This, it tells me this is the inverse of your matrix. Do you know that what we mean by A inverse means A raised power minus 1? We also write it A raised power minus 1. You can write even like that. A raised power minus 1. It will tell to MATLAB this is actually A inverse. Here you can see. No, actually B raised power minus 1 I was supposed to do to compare. B is like this. Inverse of B is like this. And B raised power minus 1 is like this. Okay. You see that whenever I wrote inverse, I asked my MATLAB to calculate the inverse of B, calculate the inverse of this matrix, which is this, and within a fraction of seconds. And B raised, I could have also written B raised power minus 1. It means the same thing. So we will go for break of 7 minutes after 10:50. And if you have any question after that, you can let me know. And then we will solve some problems. We will join back. Like everyone needs to join back at 11. Sorry, at 10:50. After that, if you have any question or any query, you can let me know. And also, so far as possible, as much as possible, try to do all this stuff parallel to me. Even if you are not able to do 100% whatsoever, but try to do it because this will give you a hands on. Until and unless you do get your hands dirty on this, like you don't learn the programming. You need to get your hands dirty. And there will be a lot more of errors than you would expect during. And you will love to solve those errors and learn from those errors. There is some message in the chat. Hello. It's 10:50. Welcome back. Let us restart where we left. We have calculated the matrix inverse using the two functions. Now, what we will do is we will solve a problem. Okay. You earlier used it to we use it to solve the problem. Okay, we have a problem, what we call a system of linear equations. Let's see how simple it gets to solve it on MATLAB. Just as simple as that. Suppose that we have a problem x in terms of three variables x, y, and z, and three equations are there, and we want to solve this. In mathematics, what we usually do it, we try to transform it into the matrix form, where we write ax equals b, and as per this, our a will be coefficient matrix. This will be 1 minus 4, 2, 1, 2, minus 2, similarly 1 minus 1, 0, depending on what are the coefficients in this, and B will be this constant matrix minus 2, 3, 4. So this is actually equivalent to this, and you might have learned this in mathematics. So whenever I have this, I will matrix to be solved, this linear system of linear distribution to be solved. I will not bother about whatever is this. I will just transform into the form Ax is equal to B. So what I actually want mathematically is I just want to calculate the x. I know A, I know B, I want to calculate the x. So mathematically, if I try to solve the x, what I will do is I will try to have x on a single side, on one side independently. For that, what I will do mathematically is I will multiply I will pre-multiply A inverse on both sides. What will then it will lead me to x is equal to A inverse B. So the point is simple. If I want to calculate the solve the this system of linear equations, I just need the two matrices A and B, constant matrix, this coefficient matrices as well as the constant matrix. Okay, so I defined it, and then I will calculate A inverse and multiply it with B, and this will give me the values of x, y, and z, or the variables which satisfy my equation. Let's try this equation out. Okay, so what will be my A coefficient matrix? Okay, I will write my matrix A as 1 space minus 4 space 2. Then I will move second row 1 space 2 space minus 2. I'll move another row 1 space minus 1 space 0. I could have, in place of space, I could have also typed comma. Okay, this is my matrix A now. I want to write the matrix, I want to write the B as a vector. So how can I write it? Can someone tell me? Because this is my so-called column vector. How can I write this? It means that I will have
Minus
three
2
things.
space minus
Yeah, minus 2.
colon, then minus 3 colon.
Yeah, semicolon. Minus 3 semicolon 4. If I would not have written semicolon, only space, then what could have happened? It would have been stored as a row matrix. So you will see now it is as a column matrix. Okay. When I try to write, now I want to calculate the x. X is my A inverse of B. Okay. I can just write my x equal, and x will have three components, x, y, and z. Okay. This is my solution x. It will be inverse of A into, okay, this B. You can see. Oh, this is the matrix is singular to working precision. It means that this is not solvable. What I will try to do is I will try to change some inputs so that this matrix is not singular, because you already know that if my A is singular, my this is not solvable. Okay, because inverse does not exist for this matrix. Now I will try to change the matrix, because I had randomly created this without any intention. Because now it will be 1 minus 4, 2, it will be 2, 2, it will be plus 3 and minus 2, 1 minus 1, 0. Okay. Now 1 minus 4, 2. Here I am changing it to 2. 3. I'm just trying so that it will not be a singular matrix and my equations are solvable. Okay. Now my A is this. I will see if inverse of A exists. Yeah, now inverse of A exists. Okay. So I have written A, B is already written there, 2 minus 3, 4. Now I know that my inverse of A exists. It means that the system of linear equations is solvable. So what I will do is I will write X as inverse of A into B. When I try to calculate, it gives me the answers. It means that first one is the corresponding to first variable, second variable, third variable. Okay, this is usually when we solve the linear equations, how will you get it? This is X, Y, and Z. X, Y, and Z, X, Y, and Z. So this will be the value of X, this will be the value of Y, value of Z. So you could have written like this: X equals A raised to power minus 1, then into B. I already told you it will do the same thing. Okay, you can see A raised by minus 1 is actually the inverse of A. And then another, you can also write it: X equals A, this left hand division divided by B. This also means the same. When you write A and this division, left division, okay, this also means the inverse. So there are three ways I have shown you to calculate the inverse. One is directly use of inverse. A raised power minus 1, you can write like this.
Sir, what is mean by left division?
In the matrix, actually, there are two types of divisions in the matrix. One is the left division, and that is the right division. For example, I have a matrix. If I use this division, do you see some change in the sign between this and this? This one is called left division. This one is called right division. Okay, let's see what will it do. Simple division, like right division means the normal division. Okay, it means that error using this because I cannot divide the two matrices, right? So here in the matrix, like right division means the normal division, and the left division means the inverse. Okay. Sometimes I want to calculate some particular properties of a matrix. Like, for example, I have a matrix A, which is this 1 minus 4, 2, 2, 3, minus 2, whatever is stored in this. And I want to calculate the determinant of A. What I will do is my determinant is equal to determinant of simple A. DET means determinant of A. Enter. This will calculate the determinant. Okay. I want to calculate I want to see what are the elements in the diagonal at the diagonal position. Diagonal position means push elements at 1, 1, 2, 2, 3, 3 along the diagonal. Okay. Along the main diagonal only. So I will write DIAG diagonal elements is equal to DIAG of A. It means it will tell me what the diagonal element in the first row, diagonal element in the second row, diagonal element in the third row, like this: 1, 3, 0, as expected. Or you know that, or you might, some of you, since most of you are third year and fourth year students, you would be knowing the eigenvalue analysis, which we usually do. And this is the most typical problem which you will see in the engineering. In almost every, like at least in the civil engineering, you will see its use in structural dynamics, like when you try to solve the eigenvalues and try to get the mode shifts and all that. So some of you might have used it and some of you might not have used this, what we call as eigenvalue analysis. Okay, because every matrix has some eigenvalues and eigenvectors, which we will not discuss here in detail, associated with it. And that's a very lengthy process if we calculate using pen and paper. So simple process for that will be, if I calculate EIG of A, it will give me the eigen values. Okay, and so here the eigenvalues are complex. This, this, okay. So, or I want to write some different matrix: 4, 5, 6, 5, 6, 7, 6, 9. This is the matrix A, and now I would calculate the eigenvalues of A. These are the eigenvalues of A. Okay, and similarly, if I want to calculate there are, other than the eigenvalues, there are associated, each eigenvalue has associated its eigenvector. Okay, if I want to calculate that, then I need to write my function like this. I don't know whether it calculates first. I need for eigenvalues or eigenvectors. For that, I will go to help EIG. It will tell me. Just see. If I simply write eigenvalue of A, it will tell me the only eigenvalues. Okay. If I write V comma D, it will tell me the diagonal one is eigenvalue and also the corresponding eigenvectors. Okay. Let us try. Let us see that. Vectors comma values. Okay. Equals EIG of A is eigenvalue of A. Values is this is the first value, second value, third value. Okay, which we had earlier also demonstrated. Yes. Similarly, corresponding to the first element, this first column, this one, and this one. This is the vector eigenvector corresponding to the first eigenvalue, corresponding to the second eigenvalue, and similarly corresponding to third eigenvalue. This one we have each eigenvector associated. Each eigenvalue has associated eigenvector. Similarly, we can calculate inverse. We can calculate rank of any matrix. You might be knowing the rank of matrix from your 11, 12, or you would be solving them. You would have solved these in the engineering mathematics part 1 or part 2. So I want to calculate the rank of any matrix A. Okay, it shows me that rank of matrix A is 2. So what's my matrix? Okay, because I want it means that determinant of A should be 0. Is it so? What's the determinant of A? Yes. It means that there is no third. Rank 2 means at maximum I can have a submatrix of order 2 which will have determinant non-zero, or it will mean that if I take any submatrix higher than order the 2, it will have the determinant 0, and I here determine that determinant of A is 0, and so the rank of matrix will be less than 3. Like if I take, then I have to evaluate all others, then see. It's a very long and iterative process. Okay, so MATLAB does it in a fraction of seconds. It calculates rank. Similarly, every vector or every has associated with every matrix has associated with it what we call as norm of a vector. We can also calculate that, and we will see that there are multiple norms. Either infinite norm, there are the we can say second norm and the first norm of the matrices. You will look them later. Okay. Now let's come to some basic plotting. How do we plot the graphs? Is this point up to this point? Is this clear?
Yes, sir.
Okay. Thank you. Now we will see the plotting, which is the very important part in MATLAB. Okay. Can someone like imagine the graph of any function in the mind? Okay. Wow. Okay, leave. I want to plot. I have a value of x, values of x, and corresponding values of y. I want to plot them. Okay. What I will do is I will write some x values in a variable. Let I will say my x variable is equal to it is equal to 1 space, 2 space, 3 space, 4 space, 5 space, 6. Okay. Then I will store my y variable equals, like I need to store it as an array. Okay, either column or as vector array, or as row vector or column vector. Okay, this is my x variable, and these are my y. I want to plot. I want a plot between x and y. You do not need to do a lot of things. You only need to do plot x comma y. but x should be whatever is the variable in which you have you have written your x variables. Here I do not have written my x variables in x. I have written my x variables in my x variable. Okay, so I need to input the name of that variable only. Similarly, I need to input the variable of the name in which I have the y values. I have written those values in this variable. So I am writing there. Then I click enter. You can see if something happens. Do you see something happening? What has happened? Like it has plotted the values between x and y, where x runs from 1 to 6 and y runs from -1 to 5. Because of when my x was 1, my y was 3. You can see when my x was 1, y was 3. Okay, when my x was 2, y was 0. When my y was -1. When my x was 2, y was -1. Similarly, when my x was 3, y was 2. You can see here 2, and this is 2. When my x was 4, y was +4, like this. So the point is that it plots the values of this is corresponding x, this is corresponding y. Similarly,
Sir,
this is x.
if we give in exponential form, x square, y is equal to x square, other functions.
Yeah. I'm coming to that. Okay. So the basic point is what it does is it plots the values, it plots between your x values and as well as your y value. So you want to plot a function. Okay. Let us suppose that you have x1. You want to plot a function of sine of x. Okay. That is plot of sine of x. And you want to plot it from the x values. Let us say that you want to plot it from, for an example, 0 to 2 pi. Okay. So I will need to create an x values from 0 to 2 pi. I already told you how to create a vector between one value and another value, number of values in between. So what I will do is I will create my x equals 0 से लेकर from 0 to something. Let us suppose that something, I don't know, I will change it up to 2 pi, 2 into pi. So I want my x values from 0 to 2 pi. Okay, but with the difference of, let us say, pi by 100. So and my x will be created. You got it? But I already know this will do. So what I will do is now I will write the x like this, and I will put the semicolon at the end so that x is created without showing me on the window. Now I want to calculate if I want to plot something, some equation, I need to calculate that. I need to calculate the corresponding values first, then I can plot. Okay. For example, here I want to plot the sine of x. So I will need to calculate the x corresponding to each value in x. I need to calculate the sine of x. Okay. If I simply do y is equal to sine of x, what it does? So it has calculated in each element. In each element, it has calculated the corresponding sine of x. Y equals sine of x means that corresponding to each x, I will have a corresponding y. Okay, you can see 1 is 1. It has a size 1 cross 201 double. It means that it's an array which has 1 rows, okay, and 201 columns. It is this much number of. You can see. Okay, if you click any value, any variable in this, you can see what are the values stored in my x. Okay, these are the values stored in my x, which is 201 values are stored in my x. When I wrote y is equal to sine of x, what it did, you can see here. If I click here y, if I click here y, I correspond to each value in the x, my sine of x is calculated here. This is what I have done using MATLAB. So I don't need to know. Now I can just simply plot x and y, But currently my x values are in x only and y values are in y only. If these would have been in some different variable, I would have written the different variable names. Enter. You can see the plot coming. Do you see the similar type of graph in the sign for the sin x when you use it to do your maths during high schools or higher secondaries?
Yes, sir.
For example, I want it now. I want my x not from 0 to 2 pi. I want it from 0 to 10 pi. Okay, like with the number of points. Let us say 1,000 with the points of with the difference of this pi by 100. Okay, I will calculate x. Then I will calculate simply y is equal to sine of x. You can see now there are 1001 points in x as well as in y. Then I will write the plot of x comma y. What it does is this what I intended to have my sine function as? If I want to calculate, let us suppose y1 is equal to cos of x. Okay, let us suppose I will choose it to store it in y1. If I want my y1 to be plotted, cos of x to be plotted, what I will do is plot of x comma y1. This is the cos function which starts from 1 when the x is 0, and then it has a period of 2 pi. Okay, so like this is the plot. Similarly, if you want to calculate the x square, you can do that. Like you can see, let us suppose y2 is equal to x square. X square, what I will do? X raised power 2. Simple. So y2, sorry, this is the x is my vector. So I will need to write x dot raised power 2. Okay. Then I will plot x comma y2. Is this the quadratic function between this and this? Y is equal to x square. Actually, I have plotted it only in this dimension. Had I plotted it negative dimension as well, like for negative x, it would have been like this, like the parabola. Let me show you. Okay. Let me show that x is equal to capital X equals from minus 2 to then 0.01 I will have difference to 2 or minus 5 to 5. Okay, I want my x to be from minus 5 to 5. Okay, then I want my y to be x dot square or like this 3, not x square, simple 3 into x square minus 4 into x plus 3. This is my y. Now I will plot any function I can plot x comma y. This is the plot between x and y. You got my point? This is the parabola. If I extended, if I would have written instead of 5 of 10, it would have gone much higher. So these values of x and x, I am choosing minus 5 to 5 or 0 to 5. This depends on the problem of the interest. Sometimes I may be dealing with the problem where I need only from minus 2 to 2. I'm interested in the values only from 0 to 1. It depends on the selecting these depends on the problem which you are solving. Okay. But you have seen that when I plotted this, let me plot this again. But you don't get anything from it. Okay. Until and unless it does
Sir,
not have.
Sir, is not symmetric.
What?
Minus 5 to 5, it must be symmetric.
No, if I would have written just y is equal to x square, then it would have been symmetric. I have written function as 3x square minus 4x plus 3.
Okay.
because I have not written simply x square. The function here is 3 into x square minus 4x plus 3. If I just write y is equal to x dot square, then I plot x comma y. Obviously, this is what we call as symmetry. Is it what you meant?
Yes, sir.
Thank you. So, clearing my command window, going back to the plot x comma y2. What was it? I don't remember. Sorry, plot x comma y2. No, I want to sign function. I have saved that in x y1. I remember. I don't remember. Okay. What I want is, see, I just want to let you know that when you plot, you don't get something out of this. You don't know what is this. You know this is the axis, this is y, but you don't know what is this. Okay. Sometimes because when you see the graphs, when you read some topic, you have x-axis as time, y-axis as something. Okay. So to make it more meaningful, I will add titles, axis labels, and all that too. See, I am plotting this. Okay. Then what I will do is I will write the x label. X label means what will be written on this axis. Okay. Then in between, I will write some string. I already told you to write a string, you will have to write it in between the inverted commas. Okay. I will write theta radians. You can write anything you wish to. Okay. Let's see what will happen. What has it written? Theta radians, whatever I wanted to. Now I will write y label. Y label means the something I am going to write on the y-axis, and this will be, let us suppose, y is equal to sine of theta. Okay, it is writing it. You got my point? Sometimes I may write title for the graph. Title will be, let us suppose, simple. The point is that whatever you will write, you have to write it inside the bracket, but inside the bracket, you have to write it in the inverted commas. In the inverted commas means it is sitting. Okay. If you are writing it as a text. Legend, my title will be plot of sine x. Plot of function sine. Sorry, sine it is. Okay, let's assume that we don't care about this much. This is the plot of function sine. So this is the title at the top. This is the x label. This is y label. So sometimes what you want is, we will come to legend in a minute. Okay. Sometimes what you want is, you want to, because we all have cos x, we have sin x. Okay. I will calculate y cos is equal to cos of x. Okay. Now I want to add to the same graph. Okay. On this graph, I want to have sin x as well as the cos x. What I will do is, since I have this, I have this. I'm working on this graph right now. I will also get to hold on. I will write hold on. Okay. Hold on means, if I give you now the command again to plot on, it means that you have to plot on this graph only. Hold on means that. Okay. So then I will also get to plot x comma y cos. Oh, this was earlier. This was cos function only. This was not the sine thing. This was the first function. Wait, let me just clear and CLC show you the multiple plotting, multiple plots. Okay, I have my x varying from 0 to, or I will use linear space. Yeah, which I have already shown you, like linear space from 0 to 10 pi, 10 into pi. Okay, but how many number of points? Let us suppose I want this much number of points. I don't know how much I have written, whether I have written 1 lakh or something. Okay, this will be the x. And now calculate my y1, in which I will store the sign. This will be the sign of x. You can see how many computations I am performing. Why I have not written this. Here I will again go to CLC. Now written as x equal to this. So x has been created. Then I will write y1 is equal to this. I will write the semicolon at the end so that this is not printed to my command window. And then y2 is equal to cos of x. Okay. Once again, I didn't mean that. I'm sorry. I didn't mean that. I forget it. So x is this, y1 is this, y2 is this with the semicolon. Okay. Now I want to plot. First of all, I will plot x comma y1. You'll see what will happen. Okay. My graph is created, right? Okay. Now I will also get to hold on. Okay. Hold on means if I plot something else, it will be plotted in the same graph. Otherwise, if I do not write the hold on, it will plot in some other graph. Plot x comma y2. Okay. You can see. But now you don't know what is this label, this label, this label. Okay. What I will write is x label is equal to theta simple, whatever this is. Okay. So it has written theta on the x-axis, and my y label will be, let us suppose that I will not write sine cos because I have both the function. Y is equal, I will write y is equal to f of x. Okay. Simple and general point I will write. Y is equal to f of x. Now, I want to add title. Title means at the top. So the title will be sine and cosine functions. Okay. It adds the title sine and cosine functions. Now I want to make sure that which is sine, which is cos. I know that blue one is sine and red one is cross. But I need to make sure, because when I'm presenting this result to someone, I need to make him understand that this one is sine, this one is cos. What I will do is, this is what we call as legend. I will add a legend to the graph, and I will tell him that the first function I have plotted, this x1, this was the sine, because depending on what I have plotted first. Legend of sine of x, let us suppose. Okay. And I will close this, comma. Second function I have plotted was cos of x. Okay. So just see what we mean by legend. Because this is usually helpful when you try to differentiate between the results, when you try to present the results. Do you see what has happened? This has been added. I can move it to some other places as I want. I can even move it using coding. As of now, I will not do that. So it shows that this green plot corresponds to what? This green plot corresponds to sin x, and this red plot corresponds to cos x. Even you can change the line styles. Like this is the line, you can change its color, whatever you want. It has chosen it as by default some random color. Now even you can, if you want, you can have it pink, you can have it gray, you can have it green, any other color. Or like this is a solid line, you can have a dashed line, you can have simple other colors. You can also keep the grid on. Let us suppose grid on. What will it do? It will apply the grid to this. Then you can see, oh, where does my function reach 0? My sine function reaches 0 here. This is around 3 pi, 3 point something, which means this is 1 pi. Okay, because sine pi is 0. So here you get some insight about how do we do plotting. This is some basic plotting, and we will be doing advanced plotting in the next session. So in the basic plotting, I have told you that you can try it out. Like you can use the different colors. Like if you want some different colors, you can use Y for the yellow. If you write the M, you can use the M for the magenta, R for red, C for cyan, B for blue, like that. If you want change the line, currently this is a solid line. So you can use dash. If you do not use anything, it will automatically choose a solid line. Then you can even use the dashed line, dotted line, dash dot, whatever you want. Similarly, you can add markers. You might have seen some graphs where markers are added. Some this circle, plus sign, or asterisk. We will be doing it in some if time permits. Okay. So this is some basic overview of plotting. So this is the MATLAB cheat sheet, which will be available for you. I will be sharing it with all of you after these sessions are over. So you can, whenever you write, like whenever you learn the MATLAB, you can keep these two sheets. You can print those two sheets. I will share the PDF with you. This contains a lot of commands, lot of the basic commands in it, and you will see that because you will not be able to remember everything. You will not be able to remember the commands. So what you will be able to remember is just keep it whenever you write any code, whenever you practice with the MATLAB, just keep this code in front of you, what we call a cheat sheet, and look into this. What is the function which I can use directly from this? Because you will not be able to remember everything. And I will share this cheat sheet with you in the form of PDF after the end of next session. Okay. And we can do some problems together if the time permits, because we have done a problem like the simple plots of sine x and then cos x, then plotting it with some different lines and all that. So I'm giving you the 5 minutes break up to 11:35, and then I will start the introduction to MATLAB, introduction to programming with MATLAB. And this is where actually the fun starts, where you have to be more careful and where you have to be more witty to learn the actual things. Okay, so we will resume at 11:35. It's 11:30 right now. I hope to see you all at 11:35. In case you have any query with regard to what we have covered in the till now, you can let me know.
Should I pause the recording, sir?
Yeah, if you wish to, you can. Or if someone asks the question, then so this is only 5 minutes break. You can even ignore to pause recording.
Okay, sir.
If anyone has any question or anything to ask about this, can let me know. Leandro, we have session up to 12, right?
Yes, sir. And then next session is from 1.
Okay. So we have lunchtime from 12 to 1, right?
Yes, sir.
Okay. Okay. I think recording is on. So let's restart with the introduction to programming with MATLAB, which is going to be the actual fun and the actual topic in this workshop. Let me clear everything. Loading with this. So now comes the programming stuff. You can imagine that, or you can recall that whatever I was doing till now, I was doing everything in command window. Whenever I was erasing something, I used it to, like, for example, I have multiple times I have written A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, the matrix. Now I have to do it again. Okay, I can't save it. This is where the programming stuff comes into play. So when we talk about the MATLAB as a programming language, we will focus on two aspects. One is the scripts in the and one is the functions. How to create the scripts, how to create the functions. Okay. What are the scripts? Scripts are actually nothing. These are the sequential collection of commands. It's actually the because we were writing each command then entering, adding each command then entering. Script is actually the collection of commands, but in sequence. Okay, which are stored in a file, which has the extension .m. It could be either very basic, like commands could be like as we did in using MATLAB as a calculator as matrix operations. Because so far we have executed commands in command window only. And I'm sorry to mention that the commands you have executed so far cannot be executed or executed several times. If you want to execute them several times, you have to retype them. Okay. So what should we do to save our efforts? What we have done? We need to do simply. We need to create a file which contains the list of commands we want to execute. We want to, when we create a file, then we will save it and run it. Only 3 points: create a file, save a file, run the file. Okay. So moving to, we will see that creating, saving, and running a script. How do we create a script? There are two ways we create a script. I have told you yesterday as well. Script means in which I will write the commands, then execute all the commands at the same time. I will click here, new script. This is the script. This is what file has been created. Okay. I will need to write my commands here. Some commands, whatever I am supposed to do. Suppose A is equal to 1, B is equal to 2, and C is equal to A plus B. Okay. Then I have to save it. Control S and name it. The final extension will be .m. I will write my first my first script .m. There are the particular rules to name the scripts as there were the rules to name the variables. Okay, if you want to start with 1, 2, or any numeric or any special characteristics, there are the restriction. Okay, it has been saved. Now, 3 points I have to do: create a file, I did that; save the file, I did that. Okay, now I have to run the file. What I need to do? Here is the run. Okay, you see, run. My file is running. Okay, A is equal to 1. Oh, all the commands are executed similarly. A is equal to 1, B is equal to 2, C is equal to 3, because C is A plus B. If I just make some small changes, put dot, and just only want to see in the command window. Okay, if I run it, because I have saved it, Control S, I am saving it and run. You can see now what has happened. My script C is equal to 3. It only shows me C is equal to 3. I do not need to write again A is equal to 1, B is equal to 2, C is equal to A plus B, even if my clear workspace is clear. Okay. So, and what I can do is I can call the editor using the command window as well sometimes, because if I do not find here, or even if I find it here, I can use it against it. I will write edit. If I write the edit and press enter in the command window, it will open up what we call as editor for me. And in the editor, I will write a sequence of commands to be run later in a single instant. Okay. Or I can open any script. For example, I have already a script here. I can double click it and it will open up in this. Okay. I will write some comments on this. Comments means which will not be executed by MATLAB. This is my first MATLAB script, and I am excited to learn new things. Okay, what we will do? For example, let us suppose that I want to solve the set of linear equations. Okay. Like this, what we have done recently. We have solved this. Okay. What we did is we used to write A. A is our 1 space minus 4 space 2, 2 space 3 space minus 2, 1 space minus 4 space 0. Okay. So what will you do? You see, this is one command. These are not the commands. The MATLAB will ignore this. This is what we call as comment. Okay, this is the command. MATLAB will create a matrix A. First of all, I will ask my MATLAB to clear all the variables in the workspace and then clear my command window. Okay, this is the command I am writing the MATLAB. Clear all the workspace. Clear my command window. Then create a matrix A. Okay, after you create a matrix A, create a vector B. I will write in a single line because I have showed you multiple commands in a single line yesterday. So I will write B equals minus 2 space 3 space 4. Is it? Am I right? Am I doing it right? Because earlier someone said no, you are not doing right. What I will do is I used to do this because I want to it as a column vector. But this time I will not do it like this. I can do it like this, but I will not do. What I will do is I will minus 2, 3, 4, then I will place transpose on this. Okay. Transpose of a row vector because if this is only this part, it means this is a row vector 2, 3, 4, minus 2, 3, 4, minus 2, minus 3, 4. If I place a transpose on this, take a transpose of this, it will automatically convert it to a column vector. So this is just another way I want you to learn. Okay, how the things work. Now I want x equals inverse of A into B. Okay. Control save and enter. Actually, my MATLAB script has been run. First of all, it has cleared all the workspace. You can see earlier whatever was there. Then it has cleared my command window. And then it has written a matrix A. This is the matrix A. Then it has written a matrix B like this. Then it has calculated X as the inverse of A in the inverse of B. But at this time, it did not print anything because I put semicolon at each. Okay, what I will do is I will just now remove the semicolon in this and calculate the run. So these are the values of x, y, and z, which the MATLAB has solved for me. Okay, hope you have got it because sometimes what I want is I may have the same set of equations, but I may have changed in this minus 2, minus 3, 4k. In place of that, I will have minus 2, 5, and this is minus 9. Let us say that. And now you want to calculate. Just you need to save it again and run. You can see now my values of x have changed. Okay, you just need to make a small change in this, and you can see how it works. Okay, this is the comments which you should always comment. I will not comment because of the time. I don't have too much time because you should always comment your scripts. You will see a lot of things which are rigorously commented because you will not get what you have written after a long time, or you will not even. Sometimes you will have to share your code with someone else who is going to use that. Okay. So this is the editor. The good thing is that I can even I have in the I have some other text editors. Let's say Notepad or Notepad plus plus. I have. I will open it. Okay, this is my distance. Okay, I can even write my commits here. I can even write something. This is my MATLAB script. Okay, then write A equals 1, B equals 2, C equals A plus B. This is the simple data. And if I save it, let us suppose I save it in my downloads as script dot dot m. Okay, I have this as script.m. I can even write this script outside the MATLAB and then import it to the MATLAB and run there. But I will not do that. Why? Because you will see. You see, as I have written this star, this percent, it shows some different color. When I have written clear CLC, it shows some different color. Here it shows some warnings also. You terminate, when I take my cursor to this, it shows terminate statement with the semicolon to suppress the output within a script. Okay, so that because you know that if I earlier I wrote here semicolon and then it showed me that you need to write. It did not print the matrix here. So it is there was showing me if you want to terminate it, just put terminate this statement with a semicolon. So it is highly recommended that when you deal with the MATLAB, you just use MATLAB editor to create your scripts and debug your files. Okay, and here you have seen that how we call the editor. I want to open this my script.m. I can either double click on this, it will open up, or I know that in this folder I have a in the same folder I am working with. This is my folder I am working. This is current folder directory. I want to open this. I can write edit edit dot edit space. It will open up this script for me. Okay, because this was not any script. My script.m was not any script. It has created a script for me, like blank script. But what I actually wanted is, I wanted to open the already existing. My first script was the name. Okay, you can see it has opened up this, and I can run it. I can make some small changes if I want, and then run it again. Okay, it gives me the values. But I have already told you yesterday that if there are already, like, let's suppose we are not using this clear and the CLC, and then we are writing A, B, or X, some Y. Y is something. Let us say 2 times X. Okay. If you already have A, B, C, or X or Y in the workspace, make sure that it will rewrite the variables. Okay. So either you have to define the other variables, or if you do not want, like you have to work accordingly. Like you have to keep in the mind that variables will be overrated. Okay. And like this is what I call as commenting the scripting. It will be highly very important that you comment your scripts, because otherwise you can't even read your own script after that, after some longer time. Now we will see, we will run some scripts. We have run the script. Suppose that I have a script, I can run it from here. I have shown you already. Okay, and I can even just I'm in this script. I can press F5 and it will run. You can see. Okay. Either I can press this or F5, or I can just write the script name here. I do not need to write my, I will only write my first script, but it knows. This is my script. So I run it from command window. Okay, did you get my point? Did you get the point?
Yes.
So what are the functions? Can someone tell me what are the functions?
Yes, sir. Hello, sir. Okay, sir. Okay, sir. No problem. I'll stop the recording, sir.